Hi class! In this video I'd like to focus on Chapter 7, Graphing Inequalities. Chapter 7 covers linear programming, and graphing inequalities is the first step to linear programming. So to graph inequalities, the steps are to first graph the equality, which means that you're first going to graph the two lines. The second step is to test a point to determine where to shade, either above the line or below the line. The easiest point to test is 0, 0. Plug 0, 0 into the inequality to see if it comes out to a true statement. And if it does, then you know you'll be shading in the area of 0, 0. The third step then is to shade that indicated area, either above the line or below the line. Where the shading overlaps is where the solutions are to the system of inequalities. So let's start off with an example. So the first step then is to graph the equality. Negative 2x plus y equals 6 and x minus 2y equals negative 4. To graph the first equality, I create an xy table. Now remember, all we need are 2 points to make a line. And so the first coordinate that I'm going to plug in for x will be 0 because it's the easiest. If I plug 0 for x here, I get negative 2 times 0 is 0, and that gives me y equals 6. So y is 6. Remember, I'm graphing the equality, so I'm graphing the line first. So then I'll find a second point on the line, and I can do that by plugging in 0 for y, and I get negative 2x equals 6, or x equals negative 3. X equals negative 3. So now I have my 2 points, and I can graph my line. The point 0, 0 is right here, so I'll go ahead and indicate that, and that'll help me find where my points are. So the first point is 0, 6, so I start here at 0, 0. I go over 0 and up 6. The next one, starting at 0, 0, means I go back 3 and up 0. And now I can make my line. So I go right through both of those points, straight as I can, and I put arrows on the ends. Always put arrows on the ends of your line. That indicates it goes on forever. Alright, so my next step is now to graph the second equality. I'll make my xy table, and I'll plug in 0 for x. And when I plug in 0 for x, I get negative 2y equals negative 4. And that gives me y equals positive 2. Then I'll plug in 0 for y, and I'll get x is negative 4. So now I have my 2 points on this second line. And graphing those, I get 0, positive 2, so up 2, and negative 4, up 0, and I'll draw a straight line through those 2 points there. Okay, so the next thing to determine is if the solutions lie on the line. If the equation says negative 2x plus y is strictly greater than 6, so no line underneath here, if it just says strictly greater than 6, then that means the solutions do not lie on the line, and I would have to make a dashed line. In this case, it's greater than or equal to 6. Then I have a solid line, and that indicates the solutions are also on the line. For these two inequalities, the solutions are going to lie on the line, and so the two lines should be solid. The next step is to test a point to determine if I'm going to shade below the line or above the line. So in inequalities, the solutions are not only on the line, but they could also be above the line or below the line. So I'm going to test 0, 0, and testing 0, 0 means plugging in 0, 0 to see if I get a true statement or false statement. If I get a true statement, then that means that 0, 0 is going to be part of my shading. Alright, so I'm going to plug in 0 for x, so negative 2 times 0 plus 0, plugging in 0 for y, and that's greater than or equal to 6. So on the left, I calculate that, and that gives me 0 is greater than or equal to 6. And in fact, that is a false statement. So that means that the shading is going to actually happen above the line, and all the solutions to this inequality lie above the line. Okay? So for our second one, I'm going to again plug in a test point, plug in 0, 0. So 0 minus 2 times 0 for y is greater than or equal to negative 4. On the left-hand side, I get 0 is greater than or equal to -4, and that in fact is a true statement. So that means that 0, 0 is a solution to this inequality. It also means that I'm going to shade below this line. Okay, so the solution set to this system of inequalities, that means the solutions that work in both the first inequality and the second inequality, is where these two shadings cross. And in fact, the two shadings cross in this area right here. And so technically, this is the only area that you need to shade, is where the shadings cross. The solutions also lie on both lines, and there are actually an infinite number of solutions because, of course, these lines go on forever, and that means the shading goes on forever as well. So any point in this area is a solution in the first inequality and the second inequality. So in this example, we're going to be looking at a company that produces shawls and afghans. This first row indicates the number of hours it takes to dye a shawl. The second number is the number of hours it takes to weave a shawl. The second row is afghans, and so it takes 2 hours to dye an afghan and 4 hours to weave an afghan. The third row is the maximum number of hours that you have available in the day to work on dyeing and weaving. So there might be one employee that is working all day on dyeing. That employee can only work 8 hours a day, and so that's known as a constraint. There's a constraint on the number of available hours you have on dyeing per day. The next one is the number of hours of weaving. So the constraint for the number of hours of weaving per day is 14 hours. Maybe there's an employee that works all day on weaving, and maybe you as a business owner only works 6 hours a day on weaving. So if x equals the number of shawls created per day, and y equals the number of afghans created per day, another constraint will be that x cannot be negative, because you can't produce a negative amount of shawls. It has to be a positive number. Y cannot be negative. You can't produce a negative number of afghans. So we're going to show this on our graph when we graph these inequalities. But first, let's pull the information out of this table and put it into an inequality. So x is the number of shawls, y is the number of afghans. So first we're going to create an inequality for the number of hours dyeing shawls and afghans. If I multiply the number of hours dyeing shawls times the total number of shawls produced, I get the total amount of time dyeing shawls. I'm going to add to that the number of hours it takes to dye an afghan times the total number of afghans produced, and that gives me the total time spent on afghans. The maximum number of hours that I can spend dyeing is going to be 8. So these hours have to be less than or equal to 8 hours. The next inequality is going to represent the number of hours weaving. So if it takes 1 hour to weave a shawl, and I multiply that times the number of shawls made, that gives me the total number of hours weaving shawls. Add that, the amount of time it takes to make one afghan, times the total number of afghans made, that gives me the total amount of time spent on afghans. And that has to be less than or equal to 14. Because I can only spend 14 hours total weaving afghans and shawls. So these two inequalities are known as constraints. And then I'm going to create my last two constraints, which says that x cannot be negative and y cannot be negative. So this is what it looks like in an inequality. The number of shawls have to be greater than or equal to 0. And the number of afghans made must be greater than or equal to 0 as well. So now let's graph what's called the feasible region. These are all the number of shawls and afghans that I can make in one day if I have 2 employees and myself working 6 hours. Okay, so now I'm ready to graph these inequalities, and I'll go ahead and indicate 0, 0 on my graph because it's a little bit hard to see. And I'll start with making an XY table. So if I plug 0 in for x into my first inequality, I get 2y equals 8, or y equals 4. So 0 for x, y is 4. If I plug in 0 for y, I have x equals 8. Now since this graph is rather small, I'm going to make every hash mark 2 units. So if I graph 0, 4, I have 0 and up 4, so this is going to be 2, 4. Now I'm going to plot 8, 0. So again, my hashtags are going to be equal to 2. So over 8 up 0, and there's my point. So the line looks like this, and arrows on the ends. Okay, now let's make an xy table for my second inequality. So xy, plug in 0 for x, and y is going to be equal to 14 over 4. 14 over 4 is equal to 7 over 2, and that equals 3.5. So it's going to be over 0 up 3.5. For my second point, I plug in 0 for y, and that one is easy, x equals 14. Okay, so let's plot over 0 up 3.5 first. So here's 2, here's 3 right in the middle, and then I'll go up half, and that's 3.5 right there, over 14 up 0. Alright, so I'll connect those 2 points, and I'll try to get it as straight as possible. So for this first inequality, we'll test a point. We'll test 0, 0 in the middle, and if the point comes to a true statement, then we know that that's the way that we should shade. So I have 1 times 0 is 0, plus 2 times 0 is 0, is less than or equal to 8. And yes, that's true. Okay, so I'm going to go ahead and shade in that direction for the first inequality. So it goes like this. And then for the second one, I have 0 plus 0, because I'm just plugging in 0 for x and 0 for y. 0 is less than or equal to 14. Yes, that is also a true statement. So that means that we're going to shade everything below the second line. Alright, so I see those two, the place where those two lines cross is right in this area right here. So now our third constraint is x is greater than or equal to 0. And then y is greater than 0, and that means that our shading is going to be in the first quadrant. So these two constraints makes our shading in the first quadrant. X is greater than 0 and y is greater than 0, everything in the first quadrant. So our feasible region then is going to be where all 4 of these shadings cross. And if you can see it, it's right here. It's here, here, up to that 3.5, up to that 3.5 point. So the feasible region is here, and that means that any point that you choose in here is going to work in the first, second, third, and fourth constraints. So for example, 2, 2 is an example of a point in that feasible region. So that means that I could make 2 shawls and 2 afghans per day. That's one possibility. It doesn't mean that I'd be utilizing all of the hours. It just means that I'd be able to produce 2 afghans and 2 shawls per day. And so in our next video, we're going to talk about how to maximize the number of items that we can produce, or the amount of revenue that we can bring in, or minimize the amount of costs. But for 7.1, I'd like to focus on just graphing the inequalities and then shading the correct area. So watch this video again if you like, and then try them on your own.